Now let's see examples. A ball is kicked at an angle of 30 degrees above. This is angle of projectile, that's theta, above the horizontal with a velocity of 10 meters per second. What is the horizontal component of its velocity after 0.5 seconds? So here we are asked to find the horizontal component of velocity after 0.5 seconds. That is, let's see. Well, but let's find the horizontal and vertical. Let's add vertical. Let's find two of them. The horizontal and vertical component of velocity after 0.5 seconds. Now, this ball is projected at an angle of 30 degrees. There is a ball here. This ball is projected, and it will just follow a trajectory, and it's projected at an initial velocity v0, which is given by 10 meters per second. And this is the angle of projectile theta, which is 30 degrees. So at an angle there is here 30 degrees. Above this angle is 30 degrees above the horizontal. So we are asked to find the value of what is the horizontal component of its velocity, that is Vx after the V final x. So from the equations of uniformly accelerated motion, V final x, from the formula that we derived earlier, V final x is the same as V0 cos theta. Because in a projectile motion, the horizontal component of velocity is equal to the final component of the final horizontal component of velocity is the same as the initial horizontal component of velocity, which is given by V0 cos theta. This is because the horizontal component of velocity is independent of the gravity, or it is constant throughout the motion. So this is given by V final x is given by the initial speed is 10 meters per second, that's 10 meters per second, multiplied by cos 30 degrees. So this is the same as 10 meters per second multiplied by cos 30. You can use calculator to find cos 30. Cos 30 is cosine of 30 degrees is equal to root 3 over 2 multiplied by, this is root 3 over 2. So simplifying 2 by 2 divides by 2, this is 1, by 2, this is 5. So this will be, this is the same as 5 multiplied by root 3. Or this is the same as multiplied by 10. This is the same as 8.66 meter. This is meter per second. Or you can write, when you take the square root of 3 and multiply by 5, you will get 8.66 meter per second. This is the horizontal component of velocity after 0.5 seconds. Here what you have to know is the horizontal component of velocity is independent of time. It is independent of time, means it remains constant throughout the motion, because the horizontal component of velocity is not under the effect of gravity, so the speed doesn't change throughout the motion. It remains the same. Let's check what about the vertical component of velocity? What about V final y? The vertical component of velocity, that V final y, is given by V0. This is given by V0 sine theta multiplied by G times T. So let's put the numbers. The initial speed is 10 meters per second multiplied by sine 30 degree minus G. Let's take for our simple calculation, to make our calculation simple, let's take acceleration due to gravity to be 10 multiplied by 0.5 seconds. So you cancel out this 1 second by this second, so that you will have 10 meters per second, and we know that sine 30 is half, minus, let's use 9.8, sorry, let's use here 9.8. Let's use acceleration due to gravity to be 9.8. Because it's not given, like if it's not given, it will be better to use 9.8. Here, let's use 9.8. So 10 meters per second multiplied by sin 30. Sin 30 is half, and 9.8 times 0.5. You just multiply 9.8 by times 0.5. You'll get 4.9. This is the same as 4.9 meter per second, and this is 5. This is by 2, 1 by 2, 5. You just simplify, cancel this by 2, 1 by 2. This is 5. So it will be, it is the same as 5 meter per second minus 4.9 meter per second, which is the same as 0.1 meter per second. So the vertical component of velocity after 0.5 seconds is 0.1 meter per second. See, now the velocity is changing, it's decreasing, because initially, by the way, the initial v naught y, v naught y, the initial vertical component of velocity is given by v naught sine theta. That is, v naught is 10 multiplied by sine 30 is half, it is 5. So the initial vertical component of velocity was 5 meters per second. So 0.5 seconds later, the velocity decreases to 0.1 meter per second, because it is under the effect of gravity. Gravity is pulling the object vertically downward. So in this case, the velocity, the vertical component of velocity decreases when the object rises, but the horizontal component of velocity remains constant because it is not under the effect of gravity. So the vertical component of velocity remains constant. The horizontal component of velocity remains constant. It is independent of the time. It remains as long as the object is moving. The horizontal component of velocity remains constant, but the vertical velocity decreases. The vertical velocity decreases and becomes 0 when it reaches at its maximum height. Let's move on to the second example. A baseball is thrown at an angle of 25 degrees relative to the ground. This is angle of projectile at a speed of 23 meters per second. If the ball was caught 42 meters from the thrower, how long was it in the air? How high above the thrower did the ball travel? So a baseball is thrown at an angle, there is a ball. Now this ball is thrown at an initial speed of, this is a throw, this is throwing point, okay? This is a throw. So it is just, it will follow this kind of path. So this is V initial, that V naught is given, it is 23 meters per second. And it's thrown at an angle of 25 degrees. So we are asked to find it if the ball was caught 42 meters from the thrower. This is the thrower. It's caught, it's here. So the total displacement, this is what? 42 meters. That's the range. That's the range. So how long was it in the air? How high above the thrower? We are asked to find time of flight, T of flight. We are asked to find the total time of flight, question mark, and how high that H max, the maximum height, the maximum vertical height above the thrower point. So we want to find time of flight. We know that time of flight, I have already derived the formula for total time of flight. Total time of flight is given by, the total time of flight is given by 2 V naught sine theta divided by G. This is the formula. So calculating the total time of flight, this is the same as 2 multiplied by the initial speed is 23 meters per second multiplied by sine 25 degree divided by 9.8 meters per second square. So this you will get sine 25. You can use calculator. Sine 25 is equal to multiplied by 23 multiplied by 2 is equal to, and dividing the answer by, you divide by 9.8. 9.8 is equal to 1.98. So approximately 2 seconds. So the ball will be in the air for, that is the total time of flight. So the object will reach in the throwing point 2 seconds after it is thrown. So 2 seconds after it is thrown, it will reach the receiver, that's the one who caught the ball. So the total time of throw, the ball will be in air for 2 seconds. And the next is what is the height above the thrower? This is a thrower. What's the maximum height that it can rise? This is a thrower. So we want to find the maximum height, H max. So after the thrower point. So we know that the maximum height is calculated by, we know that the maximum height is calculated by, H max is calculated by, this is the same as I have showed you how to find the maximum height of the object. You can just use the formula. You can just use the formula. You can use the formula. The maximum height is V naught square. You can use the formula to find the maximum height. V naught square sine square theta over 2G. So the maximum height is given by V naught square sine square theta, V naught square sine square theta divided by 2G. That is the maximum height that the ball can reach. So substituting the initial speed is 23 square, you can use 20 square, multiplied by sine 25 square, divided by 2 multiplied by 9.8. So the maximum vertical height above the throwing point is given by sine 25. You just multiply sine 25 by sine 25, multiplied by sine 25, that's sine square theta. You'll get 0.18 multiplied by 23, multiply this by 23, again multiply by 23 is equal to 96 point, this is 96.999, almost 97, 996 divided by 19.8, this is 16, 18, 19.6, that's meter, that's H max. So divide this by 19.6, then you will get almost 5 meters above. The maximum height that this object can rise above the throwing point is 5 meters. So it says how high, means we are asked to find H max. Here we are asked to find, or the vertical displacement, that means that's changing Y, or we can call it this H max. The maximum vertical displacement or change in Y is given by 5 meters. So it will rise 5 meters above the thrower point, above the throwing point.